Good afternoon, students. Hi, this is Ms. Hernandez. I know you guys are having trouble with limited reactants, so I wanted to do one more problem to help you out. So I got this one from the chapter review. Sulfuric acid reacts with aluminum hydroxide, and by a double replacement reaction, if 30 grams of sulfuric acid reacts with 25 grams of aluminum hydroxide, identify the limiting reactant. So basically what they're telling us here is that we got 30 grams of this guy and we have 25 grams of our other reactant. Okay, so reactant 1, reactant 2. Sulfuric acid has 30, aluminum hydroxide has 25. So, like I said, when you're doing limiting reactant, you're going to have to do T-charts. Okay, it's all T-charts. The first one will use molar mass to change your grams to moles. Okay, so I'm going to start here with my given information, 30 grams of H2SO4. Okay, now in order to do that, I need to do molar mass of H2SO4. Okay, and that's an O, not a 6. Okay, so I'm going to go here. I'm going to make my list. I have hydrogen. There's 2 of them. Sulfur, there's 1. Oxygen, there's 4. And then you're going to multiply by how much they weigh. Water, 101. Sulfur, let me go to my Bible, is 32.06. And then, pues we all know that oxygen is 15.999. So then you multiply, okay? Two times 1.01 is 2.02. 1 times 32.06 is 32.06. And then 4 times 15.99. 4 times 15.99, my calculator, 63.96. And then the last step is to add them up. So 63.96 plus 32.06 plus 2.02. That gives me a total mass of my compound to be 98.03 grams. And that always equals 1 mole. All right, so I'm going to put, remember, grams needs to cancel grams. So 98.03 grams of H2SO4. And we know that equals to 1 mole of H2SO4. And we have our first T-chart, and it's done. Since our numbers are on opposite sides, we're going to divide 30 by 98.03. We end up with 0.306 moles of H2SO4. And we're going to put that in another T-chart, okay? Remember, grams are gone. We still have H2SO4. We still have sulfuric acid. Now we're going to use mole ratio. This is what we learned last week. Mole ratio. Let's see. What's my coefficient for hydrochloric sulfuric acid? It's 3. So moles is on top of H2SO4. So 3 moles of H2SO4. How many now? They want us to change it to one of our products. I'm going to choose water because molar mass of water is really easy. We should already know that. So my coefficient is 6, so that's what's going to go on top, so I can switch it. Moles of water is here. And now H2SO4 and moles is gone. So now what's all left is 2.306 times 6 and then divided by 3. All right, so the answer for the last T chart or our given information will be 0.612 moles of H2O of water. All right, now I need to change moles of H2O to grams of H2O. So I'm going to go down here, molar mass of H2O. Well, hydrogens, we have 2, oxygens, 1 times 101 times 15.99 gives us 2.02 and 15.99. Add them up, and we should end up with 1801 grams. So that's what's going to go here, 1801. So our first answer for our T charts, if we start with 30 grams of sulfuric acid, we end up with 0.612 times 1801, and that just gets multiplied, ends up with producing 11.02 grams of water. Okay, now that's just the first part. We have to do the same thing for our second reactant, our 25 grams of aluminum hydroxide. Okay, so I'm gonna continue with that. Oops. All right, so I have 25 grams of OH3. That's going to go in my first T chart. Okay, so what else do I need? I need, again, molar mass of my reactant, aluminum hydroxide. So we got aluminum, there's 1. Oxygen, there's 3. Hydrogen, there's 3. We know hydrogen is 1.01, which is going to give us 3.03. Oxygen is 15.99. If we multiply 15.99 times 3, we get 47.97. And aluminum, according to the periodic table, is 26.98. So it's going to give us 26.98 times 1 is 26. Add those 3 up. 26.98 plus 47.97 plus 3.03 gives us 77.98 grams, and that will always equal 1 mole. Okay, so then 77.98 grams of AlOH is equal to 1 mole of aluminum hydroxide. So 25 divided by 77.98. The answer that will go in our second T chart is 0.321, if we round correctly, moles of AlOH3. Okay, now we have to go back to the reaction. How many moles of aluminum did we have? According to the reaction, there was 2. We're changing it to the same compound, water. So I'm going to be using the 2 and the 6. Okay, so I go back. And we had 2 moles of aluminum hydroxide is equal to 6 moles of water. Okay, whatever answer we get is going to go on the top left of our new T-chart. 0.321 times 6. Divide that by 2. We get 0.963 moles of H2O. All right. So 1 mole of water, we learned from the top one, of H2O is equal to 18.01 gram of water. So the only thing left to do is run the math. 0.963 times 18.01 gives us, so we had 25 grams of aluminum hydroxide, and that gives us 17.34 grams of water. So let's look back. We had this information for our first reactant. This is the information we ended up for our second reactant. Now, the sulfuric acid gave us the smallest amount, so that will be our limiting reactant. Aluminum hydroxide gave us more, so he will be known as the excess reactant. All right, let's go back to the question, see if there's anything else we can answer. So for the first one, if we were to identify the limiting reactant, it would be the 30 grams of sulfuric acid. Did we determine the mass of the excess reactant that remains? Well, we go back and all we do is we subtract the 17, the answer that we got for aluminum hydroxide, 17.34 minus 11.02, and that gives us an excess of 6.32 grams. Okay, so that would be the answer for the second question. And then it says to determine the mass of each product formed, assume you have 100% yield. Well, I'm not going to do that one. It's going to take too long. So we'll just leave it at that. All right. Let me know if you guys have any questions. Have a great day.